All right, so we're doing inverse functions. This is section 7.4 in the book. We covered most of this yesterday. So we talked about how everything that's an inverse function is always a reflection over the line y is equal to x. So you will have some matching to do today of graphs. So graphically you should be able to locate the inverse function. Just look for that reflection. Remember, the line y is equal to x is a line that looks like this. So anytime that you have to look for a reflection, it is, or an inverse, it's a reflection over that line. Okay. So let's see how much you remember from yesterday. What if I had a table of a function that looked like this, and I said, what would be the table of its inverse? So what would be the first point? 12, 3, 13, 4. Okay, is it really that simple?
Yes.
It really is, yes. So you just switch the x and y. So whenever you reflect over the line y is equal to x, all you're really doing is switching your x and your y. It's really all that's happening. So yesterday, whenever we had to actually find the inverse function, we had a lot of steps to go through. We had to start with our function. We made a table. We switched the x's and the y's. We graphed those points. We connected those points with a straight line. Then we looked at that line to write the equation, and we needed to find the slope and the y-intercept. And then we had to write out the function, right? There's a lot of steps just to write out the inverse function. It'd be kind of nice if we had a much faster method of doing that, right? We do, yes. You don't know it yet. You don't, but you will. It's very, very fast. In fact, it's only 2 steps long. All right, so we're going to do this in 2 steps. It doesn't require any graphing or tables or anything. All right? So it will be quick. So whether the function is written as f of x or just plain y, okay. Let's say we have negative 6x plus 5. If it is written in function notation as f of x is equal to negative 6x plus 5, you can go ahead and switch it over to y is equal to negative 6x plus 5. It's just easy to do that. Remember, f of x is just another way of saying y. So we haven't really changed any laws of math or anything. We're just writing it in a simpler form.
So is g of x and h of x still y too?
Yep, it's always just the output. Yep, good point. Okay, so we still haven't really started a step yet. This was just rewriting it using a y instead of function notation. Step 1. I know this should not be a shocker to anybody, but we are going to switch. What? What do you think we're going to switch? What have we been switching so far today? Yeah, we're going to switch the x and y. So we're not going to switch the whole term. Just wherever you see a y, you're going to write an x. And wherever you see an x, you're going to write a y. So we're going to write x is equal to negative 6y plus 5. So that's step 1. Step 2, solve for y, which you've been doing ever since you started pre-algebra, either in 8th or 9th grade. Solving it for y. All right, what would be our first step to solve this for y? Subtract 5. So we're going to write x minus 5 is equal to negative 6y. One more step. Everybody. Right? Now you can write it like this. X minus 5 over negative 6. You can leave it just like this. Are you listening? That is the inverse function. So all we did was switch the x and the y, and then we solve for y. It's actually easier if you leave it in this form and not break it up into two different fractions. Because when we go back to check our work to see if those really are inverse functions, remember how at the very end yesterday, step 6, we did f of g of x and simplified it? We made a composite function. And then we did g of f of x. Remember that part at the very end? And they both simplified to x. That was what we call verifying that they're inverses. And as long as we don't simplify this anymore, verifying that they're inverses are pretty easy. So in yesterday's work, when we wrote our new function, we called it, instead of y, we just called it g of x, right? Now you don't have to call it g of x. I'm just doing it for this example. So that way it makes sense when we say, let's find f of g of x. This is called verifying to make sure that it is actually a good inverse. Then we're going to verify using g of f of x as well. All right, what does the f function do? Tell me in words. Negative 6 times what? Something. Plus 5. What is the something we're going to use? X minus 5 over what? Negative 6. Can you see why we wouldn't want to break that up into two separate things now? Two separate fractions? Because now the negative 6's simplify right away, don't they? So when we go to simplify, now I just have x minus 5 plus 5, which is just x. Now let's verify using g of f of x. What's the g function do? Something minus 5 divided by negative 6. What's the something? Negative 6x plus 5. All right. Let's go ahead and simplify. Plus 5 minus 5 makes 0. So that gives me negative 6x over negative 6, which is just plain old x. So as long as they both simplify to x, you have now verified that these are good inverses. So when you come up and ask me, hey, Mrs. Stauffer, is this a good inverse? Did I do this right? I'm going to ask you, well, have you checked f of g of x yet? And g of f of x? Let me see your work. And I'll have students that come up and they'll show me the initial just like negative 6 times x minus 5 over negative 6 and then plus 5. They won't show any like other work and they'll just say equals x. Like they won't show any like actual simplifying part. They'll just show the substitution part and then say equals x. And then they'll show g of f of x and they won't show any simplifying. They'll just say equals x. Like you're not tricking anybody. I know what the answer is. So I'll have students try that on a test. Like if I say verify that these are inverses. And then they'll put them in and they'll just say equals x. You have to show the work for you to actually verify it. Just telling me that it's x and just like hoping for the best is not a good plan, right? So do you have to verify each and every time? No, I'm not asking you to verify it every time. But if you're wondering if what you did was correct, that is a way to verify that what your answer was. Making sure that it was correct. Does that make sense? It's a way for you to check your work. And it doesn't really take very long. But before you come up and ask, was this right? That's something you should do. Let's just try one more example. Let's try this one. F of x is equal to 3 x to the 4th power. What should I do first? Before I do that, change that to y. Okay, now we're ready for step 1, which was to do what? Switch x and y. And now what? Yeah, say it. Divide by 3. Okay.
Would you, fourth root?
4th root it, you bet. So I have the 4th root of x over 3 is equal to y. I'm not requiring that you simplify and rationalize that denominator at this point. It's actually easier for you to verify if you leave it in this format. If you go back and you do f of g of x and g of f of x, it's a lot easier if you just leave it in this format. So you're okay to leave it like this. Make sense?
Yes.
Okay. That's really all there is to it. Switch x and y, solve for y. 2 steps. So the practice problems I want you to do in class today are found on pages 426 and 427. I'm not going to give you enough to fill the whole hour, because when you're done, I'd like you to make sure you've done pages 404 and 419, because all of that will prepare you for tomorrow's quiz. So on pages 426 and 427, I'd like you to work on the following problems. Number 14, 16, 19, 22, 33 to 35. These are the matching ones that are visually trying to match up the graphs with their inverses. And then 36 and 39. This does not get turned in today. This is for you to do in class. This is so you can avoid having homework. And then when you're done, then you can go back, and if you need to finish 404 and 419, you've got the remainder of the hour to do that.